Hi, this is a short demonstration of our tool, the K program verifier, instantiated with the semantics of the Ethereum virtual machine. Our tool can be used to verify EVM bytecode. So let's go ahead and see how the tool works using a simple Solidity contract. What we have here is a simple contract which we call demo. It just has one function called add, which takes as input two unsigned integers of size 32 bytes and just returns their sum. Now let's go ahead and see what the correctness specification for this particular program looks like. So the tool understands specifications in simple INI like syntax. So what we say in this particular INI file is that in order for this program to be considered correct, the K cell must go from the execute construct to halt. The status code construct cell should go from something that we don't care about to eventually EVMC success. That means that the program should end successfully. The output cell should have on top a symbolic variable z. The call data cell specifies that we make a call to the add function in the contract with two symbolic variables x and y, which are unsigned integers of size 256 bits. And over here we specify what the constraints on those symbolic variables are. So on symbolic variable x, the constraint is that it should be greater than 0 and less than 2 to the power 256. Similarly, we have a similar constraint for y, and for the program to be considered correct, the variable z should be the sum of these two variables x and y, right? So let's go ahead and see what happens when we run this program with our tool. So in order to make the tool understand that we want to run it in the proof mode, we pass it the flag proof and we give it the specification. So the verifier isn't able to successfully verify the program. And the reason is a very subtle bug that exists in our code. Let's take a look again. If you notice closely, you'll see that there is a possibility of an arithmetic overflow. We don't actually place any constraint on the sum of x and y itself. So it may be the case that when x and y are sufficiently large, an arithmetic overflow might occur and z may not be equal to the sum of x and y. So let's go ahead and add the condition that the sum of x and y is actually never greater than 2 to the power 256, and let's see what happens. Let's run the verifier again. And there we are. We have true, which means that the verification went through successfully and the verifier was actually able to prove the reachability logic formula that we have over here. Thank you.